Okay, today we're going to learn about the derivative of trigonometric functions. And a lot of times we're going to use the chain rule when we deal with this. So as you'll see when I did my formulas here from the notations, I have the derivative with respect to x of the sine of u. So let's talk about see what that would be equal to. And that is cosine of u, and then times by the derivative of the inside function, which is du of derivative of u with respect to x. So the derivative with respect to x of cosine u is negative sine u times the derivative of u with respect to x. And the derivative of tangent u with respect to x is secant squared u times the derivative of u with respect to x. And the derivative with respect to x of secant u is secant u times tangent u times the derivative of u with respect to x. And the derivative with respect to x is cosecant u is negative cosecant u cotangent u times the derivative of u with respect to x. And our last trig function's derivative with respect to x of cotangent u is negative cosecant squared u times derivative of u with respect to x. Now, there's a lot of formulas here to memorize, and yes, you will be required to memorize these, but some things you might notice. The three trig functions that start with c, cosine u, cosecant u, and cotangent u, all have derivatives that are negative. Also notice that the derivative of sine and the derivative of cosine are closely related because the derivative of sine is cosine and the derivative of cosine x is negative sine x. Also, the derivatives of secant u and cosecant u are closely related. They're the ones that have two trig functions. Derivative of secant x is secant x tangent x. Derivative of cosecant x is negative cosecant x cotangent x. And the derivative of tangent and cotangent are closely related. They're the ones that have the square. The derivative of tangent x is secant squared x. Derivative of cotangent x is negative cosecant squared x. All right, so let's use this to try to figure out some derivatives. So let's look at our first example here. The derivative with respect to x of tangent x times secant x. Well, and the first thing you have to notice, we got tangent times secant, so tangent times sine is a product rule. The product rule means that we're going to have to take the first term times by the derivative. Second term, derivative of sine of x is cosine x, plus the derivative of the second term times by the derivative of the first term. Derivative of tangent x is secant squared x. And then we're going to simplify. But when you simplify these trig ones, you have to often remember your trig identities. For example, I recall that tangent x can be rewritten as sine of x over cosine of x. And I'm timesing this by cosine of x. The reason I did that is so that I can cancel out this cosine of x and simplify that first term to simply sine of x. So my answer is going to be sine of x plus sine of x times secant squared x. Okay, I want you to try the second one. The f of t is equal to cosine t divided by t. Okay, so first thing I notice, I have the quotient rule. So I got to do low d high minus high d low over low low. So find this derivative here. Low is t times derivative of the top, which is negative sine of t, minus, so that's low d high, minus high, which is cosine of t, times the derivative of the bottom, which is 1, all over t squared. Simplifying this now, I would rewrite this as negative t times sine of t minus cosine of t all over t squared. And there's nothing I can simplify. Okay, let's look at some little bit more complex functions where we have multiple inside functions. So we have to add extra links of the chain rule to it. So looking at this problem here, notice that x plus cosecant of x cubed plus 3 is inside the negative 3 power, that power rule there. And then also, x cubed plus 3 is inside the cosecant function. So I have two inside functions. So you're going to start outer in. So we're going to start with our most outer function. And to find the derivative of y with respect to x, I'm going to take all of that yellow to the negative 3 power. So I'm going to do the power rule and bring that exponent to the front and put everything that's inside the bracket and then decrease my power by 1 to make it to the negative 4th. And then I'm going to use my chain rule and times this by the derivative of the inside. Well, our first inside function, or the most outer inside function, is the yellow function, which is x plus cosecant of x cubed plus 3. And I differentiate that, I get 1. And then the derivative of cosecant is negative cosecant of x cubed plus 3 times cotangent of x cubed plus 3. And then just that term, I need to now multiply by the derivative of that inside function, which is the on inside, and I need to multiply it by 3x squared, because that's the derivative of x cubed plus 3. Now I'm going to have to clean this up a little bit. So the derivative of y with respect of x is going to be equal to negative 3 times x plus cosecant of x cubed plus 3 to the negative 4th power. And I can leave that negative exponent since my problem had a negative exponent. Times it by 1 plus. Now I need to multiply that 3x squared by that negative 1 to get negative 3x squared. Cosecant of x cubed plus 3 times cotangent of x cubed plus 3. And that is my answer. As complex as that looks, I can't simplify that down any. All right, you try this your term problem. Let's find the derivative of f of x is equal to cosine cubed of sine of 2x. Now, this one thing that you'll see a lot in trig functions is how we write something raised to a power. So I will give you the hint on this first one. Every time I see a trig function like a cosine cubed here, I would rewrite it on my graph, on my paper, as the cosine of the sine of 2x, and all of that is to the cubed power. And so my most inside function is cosine of sine of 2x. Then I have an inside function of that of sine of 2x, and inside of that is 2x. So now you try finding this derivative. So my first inside function is that cosine of sine of 2x. So my outside function is to the 3rd power. So I want to find that derivative first. So f prime of x is going to be equal to 3 times all of that yellow. And then decrease my power by 1, so that's now going to be raised to the 2nd power. And I need to times that term by the derivative of the inside. So the derivative of the inside is the derivative of the cosine of the sine of 2x. So the derivative of cosine is negative sine of the sine of 2x. And then inside this function, I have an inside function. So inside the sine function was the sine of 2x. So I need to multiply this by the derivative of that sine of 2x. The derivative of sine is cosine. So the derivative of sine of 2x will be cosine of 2x. And then I still have an inside function. Inside this cosine of 2x function is the 2x operation. So I need to times it by the derivative of 2x, which is 2. I finally finished all the links in the chain. So now we're just going to simplify. So we're going to combine like terms. So first thing I notice, I have a 3, a negative 1, and a 2. So I'm going to multiply those together to get a negative 6. And then I'm going to rewrite that cosine of sine of 2x quantity cubed as quantity squared, as cosine squared of the sine of 2x. So that square, we move back into that, to our final answer. We're going to always put in that form for trig. And then I'm going to times this by the sine of 2x. And that's going to be times by the cosine of 2x. And that is your answer. We can't combine any of these terms. And so that's how you find the derivative of trig functions.